Let's continue with gear manufacturing. There are several ways to manufacture gears, but if you want to have an high quality gear, then at some point of your manufacturing processes, you need to do machining, remove material from the work pieces, and try to obtain high quality gears. And as you know, we are using gears a lot in small sizes and large sizes, depending on their function, but they are mostly used to actually transfer some rotational motions from one point to another point. And during this transfer, the efficiency is highly important. But if you manufacture them by using some primitive ways, if the quality of manufacturing is not good, if the surface quality is not good, then you will have some inefficiencies in terms of energy transmission. And furthermore, due to again some manufacturing problems, you may have vibration, chatter, and some noise during the motion of these gears, and you will not be happy about the result of your manufacturing, and maybe do another manufacturing and use another set of gears. So that's why in this little brief section I will be discussing some types of gear manufacturing, and you will see that there are several ways, but they're not easy to employ. And we can say that there are two types of gear manufacturing. The first one is called form cutting. It's highly similar to forming or form milling operations. And the other one is generating. By generating, we mean that by using some gear pairs or rack and pinion type of things, mechanical elements, we are actually generating the teeth. But in the form cutting, we are machining them from the blank part. In the generating case, they are generated during their relative motion. So this is the main difference. Now let's have a look at form cutting, how we do it. I will show you an image here. This is an example of a form cutting. We start with a gear blank. So gear blanks are actually kind of this shapes, and then what we do on them, we open such teeth, and in the form cutting, we somehow fix this gear blank on maybe some kind of a table, and then what we do with our milling cutter, we remove material for a single tooth. This is the case as you see. And once you are done with a tooth, then what we do, we rotate this gear blank a little bit and open another tooth. So this is how we proceed in the form cutting operation. It's not complicated. The principles is simpler, but you need to use proper tools. The size of the width of the tools are highly important. Their cutting edges, their hardnesses are important to obtain high quality surfaces. And they can only be used to obtain constant width teeth. If your width is actually changing along your cross section, then you cannot use form cutting. You should go with generating type of manufacturing processes. So that's why we cannot use them to manufacture bevel gears, but for spur and helical gears, since the width of their width between the successive teeth is a constant value, so they are possible. They can be manufactured with form cutting, but for bevel gear, you should go with generating type of manufacturing. And we discussed broaching, if you remember. They're highly suitable, especially for internal teeth, and their accuracies are quite fine. If it's possible for you, you may go with broaching. It's a highly simple process, but the thing is that you need to have a special tool, a special machine. So if the number is low, then you may not use broaching. But if you are doing a medium-sized production or mass production, then broaching might be the best option for your gears. And on the milling machines, you can do form cutting. The thing is that you need to use a dividing head. How you are using that head, you mount your actually gear blank into that head, and then you can set this angle, set the degree of your rotation with the help of this dividing head, and then with the help of your horizontal milling cutter, you can go into these tooths and try to open the profile. And then we have actually the second type of process is gear generating. We have three options. We can use pinion shaped cutters, brake shapers, and hubs. Now I will show you all of these on this images. And here you can see an pinion shaped type of cutter. This is our gear cutter, and this is our gear plank. The blue one is gear plank. So they are all rotating, so they are in motion with respect to each other. But this one, this gear cutter, obviously have sharper edges. It's harder than the gear plank, and it can remove material during this motion. And once actually it goes into the teeth enough, then you can finish this process. And if you have some thickness, you may also have an reciprocating motion in this vertical direction. It's also possible if the thickness is quite higher. We can also use rake shape cutter for gear generating. Again, they should be moving in a reciprocating manner, and depending again on the thickness of your gear blank, your rake shape cutter again may go into your gear blank in a reciprocating manner, but usually they have the same thickness, or the thickness of the rake shape cutter is a bit higher than the thickness of the gear blank, so you don't need to do reciprocating motion. But it's mostly possible with the pinion shaped gear cutters. And then we have an hubbing option. This is the last type of gear generating. It's quite different with respect to other ones. And the hubs, what do we have? We have many cutting edges, as you see. You have slots and many cutting edges installed after each other. They are quite difficult to obtain, expensive, but the advantage is that they are flexible. You can machine even some bevel gears. This is, for instance, bevel gear, and we can do it with an kind of a hubbing operation. So we can say that although it's quite difficult, expensive, we can produce different size of different types of holes and gears, teeth. Another thing is that in the hubbing process, we only have rotational motion. We don't have reciprocating translational motions. It's not valid for hubbing operation. And as I said, since they are quite flexible, their accuracy is much better than the previous gear generating operations. That's why they are highly used in industry to manufacture such gears. And we can further use, instead of these special type of processes, you may even use CNC type of milling centers or the machining centers to machine such gears. We know that the bevel gears are the most difficult type of gears to be manufactured. For that, you need to do maybe some roughing operation with form cutting, and then you may do some gear generating operations to obtain your final teeth on the bevel gears. And lastly, I can say about gear manufacturing is the finishing operations. Since the resulting surface quality may not be good enough after form cutting or gear generating, then what we need to do some finishing operations. And we may do simple shaving. So shaving is actually, if you remember, we talked about it briefly. You need to have a proper shaped cutter, and it's very similar to conventional shaving. So with again reciprocating motion, you may remove little material, small amounts of material from the surface, and try to increase its surface quality. But the production of the cutter, the manufacturing of the cutter is quite expensive, so you should consider it accordingly and try to find a better manufacturer for your cutter and try to decrease its cost. But you know that it's one of the most commonly used gear finishing operation, not complicated since You simply have a tool which have sharper edges, and by removing less material, you can increase the quality. Then we have the second finishing operation. This is actually a bit different than the previous one. This one is not removing material. It's actually shaping, it's forming the surface. So we can say that there's a kind of a plastic deformation on the surface. We do it with the help of some rollers, harder rollers. And since we do plastic deformation, we have metallurgical changes on the surface due to the compressed viscosity, residual stresses. The overall strength and the fatigue life of these gears actually improve. So you can say that it's useful for increasing the fatigue life of gears. But in terms of dimensional accuracy, they're not as effective as shaping process. Its main function, main aim is actually to increase the fatigue life. But if you want to increase the dimensional accuracy, then you may go with shaving, or you may do some super finishing operations like grinding, honing, and lapping. And that will give you the best dimensional accuracy you may have in the gear manufacturing. It's an example of a gear grinding or grinding process on the gears. This is the already machined manufactured gears, and with the help of these grinding wheels, the accuracy of the gear can be improved, the burrs can be removed. We have different options of the grinding, but the fundamental is the same. You have a kind of a grinding wheel. By moving it over your teeth, you can increase the surface quality and your dimensional accuracy. And lastly, I can talk about briefly on the cost of this gear manufacturing. Actually, American Gear Manufacturing Associations have a kind of a quality index. And if you look at this plot, if the quality index is increasing, which means that your dimension tolerances are getting better. If the tolerances are better, then you need to spend more money on the gear manufacturing. And gear manufacturing is one of the most complicated, most difficult manufacturing operations in industry.